Hi again. So this is the second part of the lecture regarding the topic of integration by parts. So here I'll be solving a few problems. So here are the problems that I picked. So the first problem is this one. So integration of x e to the x dx. As I stated in the last lecture, I will let my u to be x so that when I take a derivative, the order of it becomes smaller. So if u equal x, then du is going to be dx. And dv is e to the x dx. Then v would be 1/2 e to the 2x. Okay, so now I have my u, I have my v in here. So I'm ready to plug into the formula and find my solution. So it's going to be x times 1/2 e to the 2x. So this is u, this is v, minus integral of v, and du is dx. So this one is going to stay the same, x over 2 e to the 2x. The integral of 1/2 e to the dx, this one would be simply 1/2 times 1/2 e to the 2x. And you add the constant. Then let's simplify this one a little bit more. So it's going to be x over 2 e to the 2x minus 1/4 e to the 2x plus c. So that's the final answer. Okay. Let's move on to our next problem. Let's see. So here I will choose my u to be natural log of x rather than choosing square root of x, because we know that natural log of x doesn't have a direct form to integrate it. So let's start with u is natural log of x, then du equal 1 over x dx, and dv is square root of x, which is 2 power 1/2 dx. Then v is going to be x, simply add 1 to the power and divide by the new power, which the same as multiplying by the reciprocal of the power, which is 2/3. Okay, so I have now u, du, dv, and v, and then I'll plug into the formula, and let's see what happened. So natural log of x, this is u times v minus integral of v du, 1 over x dx. Well, x to power 3 over 2 divided by x, this one will simply just becomes x to power 1/2. Then this one would be gonna stay the same, times 2/3 x to power 3 over 2 minus 2/3 Now integration of x to power 1/2 is going to be 2 power 3 over 2. Just add 1 to the power. And when I divide by the new power, I'll simply multiply again by 2 over 3 plus c. So let's write this one in a little bit more better form. So this is going to be 2 over 3 x to power 3 over 2 natural log of x minus 4 over 9 x to power 3 over 2 plus a constant. And that's all. Okay, let's move to another problem. So here I decided to change the variable. So I'm using z instead of x. Well, I guess by now you would simply choose u to be z. Or no, actually, yeah, we have natural log of x. I will choose my u to be natural log of z, then du 1 over z dz, and dv would be z dz, then v equal z squared over 2. Okay, very important note here is because I choose u to be natural log of z because we don't have a direct form to integrate natural log of z. So it would be better just to choose u to be natural log of z and then integrate the other term. Let's apply the formula and see what happens. So so u times v, so z to power 2 divided by 2 natural log of z minus integral of v du, which is 1 over z dz. Well, obviously this got better. So this one becomes z squared over 2 natural log of z minus integral z squared divided by z simply will give you z dz. Okay, and this one would become z squared over 2 natural log of z minus z squared divided by 2, and I already have 1/2, and this one becomes 4 and plus c. Okay, that's the final answer. Okay, let's move. This is our last problem for today's lecture. Here I'm using m. So the solution to this problem is I can write this in this form, negative m dm. So I will choose my u to be m, then du is dm, and my dv is e to the minus m dm, then my v equal negative e to the minus m. So I have what I need. So let's plug into the formula. U times v minus integral of v, well, v is negative, with this negative becomes positive, e to the minus m, and du is simply equal to dm here. And this one is gonna stay. And integral of e to the minus m is simply minus e to the minus m plus c. And that's the final answer. Okay. I hope the second part of the integration by part topic is clear and useful. So I just wanted to solve a few problems to clarify the idea in a better way. So I hope this was useful. And yeah, that's all I have. And stay tuned for the next lecture. Thank you.